So today we're going to start chapter 1, section 1. Today we're going to, basically put down the foundation for everything we're going to be doing this year in geometry. So today we're going to talk about points, lines, and planes. So the first thing we're going to do is define what a point is. And a point is a single dot. It's the simplest figure in geometry. It can be named by a capital letter. And all geometric figures we're going to talk about this year consist of points. Now, they're going to also maybe ask you to describe if a point has dimension and a point has no dimension. So meaning it doesn't have any size to it. Now, when it talks about here, all geometric figures consist of points, when we get to start talking about, say, triangles, a triangle is made up of 3 points. We could call them A, B, and C, and then we can connect those points. And once we make those connections, it now forms a geometric figure, and that particular figure here is called a triangle. So all geometric figures consist of points. Okay. Next, we're going to define what a line is. And a line is a geometric figure consisting of at least 2 points. It extends in 2 directions without ending, so it goes on forever. An example of what a line looks like, it's going to have a straight line, but what indicates that it goes on forever is because it's going to have arrows on the 2 ends. And again, we need at least 2 points on that line or to create a line. You can name a line by 2 points or a single lowercase letter. Always remember that there is exactly 1 line through any 2 points. So down here is a picture of a line. And I can enlarge the arrows. So I can name this line, and this over here is a lowercase letter L. I know it looks sort of like a 1, but this is a lowercase letter L in italics. So whenever there's like an italics lowercase letter, you can also name a line by using that lowercase letter. Now, here at the bottom are 3 different naming or ways to name this line that's pictured. You can either spell out the word L-I-N-E and then name 2 points on it. Instead of writing the word L-I-N-E, you can draw a picture of a line on top of the 2 points. Or again, name it with the lowercase letter. When I go to name my line, the order of the points doesn't matter. So I can also call this line BA. So if it's AB or BA, the order that I write the letters A and B doesn't matter. Now, when we were taking all of our tests on Canvas, for some students using the equation editor on Canvas was a bit challenging. So what a lot of students did last year, instead of using the symbol for a line, they just used this technique of writing the word L-I-N-E and then the 2 points that were on it. Any one of these ways to name a line is acceptable. Just like before, we saw that a point has no dimension, a line has 1 dimension. Now, these naming conventions that we're learning right now, we will use throughout the school year. So it's going to be important that you understand what the little symbols look like when we see these in questions. The next thing we're going to define is a plane. In a plane, a geometric plane is suggested by a floor, a wall, a tabletop. Generally, it's a quadrilateral shape. Now, what's difficult to imagine is that a plane extends without ending, and it has no thickness. So if I talk about a plane being a tabletop, you have to imagine that that tabletop continues forever. It just doesn't stop where the table ends. So a plane, just like a line, goes on forever in every direction. And then although it has no edges, it could still be shown like that picture, that red parallelogram down here. This is how a lot of textbooks represent a plane, by a quadrilateral shape. And in this case, plane M down there is a parallelogram. And that'll be coming up later on. The naming, or ways that you can name a plane, you can name it by a single capital letter, as long as that capital letter doesn't have a dot next to it, because then it would be just a point. Or you can name it with 3 or more points that are contained within the plane. So let's say I add some points to this red plane. Let's say I put a point A and then B and C. Because there are 3 points labeled in that plane, I could name this plane, instead of calling it plane M, I could call it plane ABC. There's no shortcut for plane. You actually have to spell out the word P-L-A-N-E. And a plane has 2 dimensions. So a plane, you need 3 points, a line, at least 2. Yes?
You see how the M is inside the plane?
Yes.
Would you add that to like the plane ABC?
Well, because the M doesn't have a little circle next to it, a little dot, they're just calling that plane M. So if there was a little dot next to it, then you could have used that as one of the letters, like I did for ABC. Yes?
What are dimensions?
I'm sorry?
What are dimensions?
Dimensions are like a 3D figure. Like, where's my box? So like when something like this line, like say my stylus, this is a line and it has 1 dimension. It's only 1 dimensional. It doesn't have 2 different dimensions to it. Like this plane has 2 dimensions. Like you can look at it, it's like, well, this is actually like 3D because it's a solid. But like a plane is 2 dimensions. Uh-huh. Everybody good there? All right, let's go to the next slide. And the next one is defining space, collinear, and coplanar. So space is the set of all points. Collinear means that points that are all on one line. So for example, if I were to draw a line, and if I put points on it, A, B, and C, when all the points are on the same line, they're said to be collinear. So I could say that points A, B, and C are collinear because they're all on the same line. If I were to draw in another point and put it up above the line and call that D, that would be an example. I could say that A, B, C, and D are non-collinear because point D is not on the same line. When I talk about points being coplanar, that means that the points are all on the same plane. So again, I could draw my quadrilateral here, and I could put 3 points in here. You need at least 3 points that are not on the same line to name a plane. So Y, X, Z. So I could say that points X, Y, Z are coplanar because they all are inside that quadrilateral figure. As soon as I add maybe a point up above it, I could call that W. Then I would say that points, and I could pick any 3. I could say WXY or even WXYZ. Doesn't matter if I name them all or not. These would be non-coplanar because point W is not inside the plane. It's up above it. Yes.
Is the arrow and the point dust with the spaces?
The arrow is, so let's see.
What is the space?
The space is just the set of all points. So points anywhere. Anytime you have a group of points, that's considered space. But if those points, then it starts to get specific. Then if they're all on the same line, then they're called collinear. And then if they're all on this in the same 4-sided shape, then they're coplanar. Does that make sense?
Yeah.
So the arrow here was just pointing, at first I was just pointing to the plane, and I was talking about these being coplanar. And then you had the non-coplanar as soon as you include W. The next slide is the definition of a segment. The line segment AB or segment AB consists of endpoints A and B and all points on line AB that are between A and B. So a line goes forever, but a segment has endpoints. It stops. And the letters, when you name the segment, those are the endpoint letters. So notice here, again, you can name a line segment by just writing the word segment and then listing the 2 endpoints. You can also just put the capital letters, or you could put the capital letters with a picture of a segment on top, no arrows on it. And then another key thing to remember, just like the line, the order that you write these points doesn't matter. So I could also call this segment BA. I could put it this way, or I could also spell out the word segment BA. So the order of the letters doesn't matter. Just remember those letters need to be the endpoints, where it starts and stops. And that is considered a segment. Now, if they said that, let's say it was line AB, so you would indicate line AB to look like this with the picture of the line. But if I was only referring to the segment portion, then I would do AB either with a line on top or just the capital letters. No arrows. So that's how you can tell the difference when they're talking about the whole thing that goes forever, meaning the line, or just a little piece of it, meaning the line segment. The next term we're going to talk about, the ray. The order matters here. You can't switch them up. So for array, the first letter is going to be the starting point or the end point. The second letter, when we name array, is going to be the end of the ray that keeps going. It's going to be the letter that's close to the arrow. So for example, ray AB, so this right here, is this picture right here. Notice it's starting at endpoint A and continuing, unending towards B. But when I write ray BA, and again, that's going to be this picture. And let me use a different color. Do that one in blue. Notice they're pointing it to the left, but it really doesn't matter. I can also draw ray BA as long as the end point, the side that doesn't have the arrow, is first. You would write it there, and you can point it that way. So the direction that the ray points doesn't have anything to do with the order of the letters. What you're looking at is the first letter when you name the ray is the end point. The second number is the letter or the point near the arrow. So here, the order would matter. I can't switch it up. The end point always has to be the first letter. Now we're going to talk about if we put two rays together, how we can turn them into opposite rays. So here it says, if point C lies on line AB between A and B, then CA and CB are opposite rays. So for example, CA is going from endpoint C to the unending direction of A. And then endpoint or ray CB is going to go from endpoint C unending towards point B. Notice they both have this first letter, this endpoint, in common. So they both have the same endpoint, but they point in opposite directions. So opposite rays always share an endpoint, and then they point in opposite directions. So again, if you were to draw again, notice how CA is this way, but if my line here, AB, and C is in between, even though the arrow is pointing to the right, CA really in the line itself goes in that direction. So the picture on top of the ray doesn't necessarily tell you the direction it points. You just have to look at the letters. So the red one is the CB and the blue one is the CA. Let's talk about intersections. So intersect means to meet or to cut through. So as you're starting to learn how to drive, when you're driving a car and when two roads meet or cut through or cross, where there's a street light or a four-way stop, that is an intersection. So in geometry, when two lines meet or two planes meet, it's where they intersect, it's where they meet. So the intersection of two figures is going to be the set of points that are in both figures. So for example, if I have two lines and I intersect them, the points that are in both figures would be the intersection. So notice two lines are always going to intersect in one point. However, the picture here, this is a picture of two planes. I've got a plane flat And then I've also got one going through it up and down. Notice the intersection of two planes is this line that's right here where they meet. So the intersection of two planes is always going to be a line. Now, when you see some of these three-dimensional or two-dimensional figures, the dashes in the diagram would be parts of the picture that would be hidden from view. Maybe they would be behind something or underneath. So anytime you see dashes in any of the pictures, that would just indicate that's something that's hidden from view. Let's see some examples. Now, these are just true-false questions. Sometimes what we do a lot in geometry are questions instead of true-false. I give you questions where you have to answer it as it's sometimes happens, it always happens, or it never happens. And those sometimes, always, and never questions are sort of like true-false on steroids. They're a little bit more challenging. But we're going to start out nice and easy with this first section. We're just going to do basic true-false. Now, in these particular questions, 1 through 9, notice no picture or diagram is given to us. So sometimes it's just a question. If it helps you to draw a picture, I highly recommend it. The next slide actually has a picture. But let's go ahead and do this one. When it helps us, I'm going to draw a picture for each question. So number 1, tell if it's true or false. Line PF ends at point P. Correct. What do we know about a line? Beautiful. So if I were to draw myself a visual, remember it's got arrows, so this is false. Nice. Lines don't end. Point S, let's put a point S here. Now this one's sort of hard to visualize, but it says point S is on an infinite number of lines. So if I were to draw a line through this way, through that, through this way, this way, this way, I could keep drawing lines even though my space is kind of limited here on the paper, but there is, by definition, an infinite number of lines through any point. So this one is true. The next one is right from the slide. A plane has no thickness. True or false? True. Perfect. That is true. Collinear points are coplanar. All right, so let's draw a line. So I have some lines that are collinear. I can for sure draw a plane around them, and they would still be in the same plane. So this one is true. So collinear points are also always coplanar. Planes have edges? That's false. No edges on planes. Remember, they go forever. Two planes intersect in a line segment. False. They always intersect in a line. Remember, planes go forever, and so do lines. So if the question were two planes intersect in a line, then it would be true. But because they have the word line segment, that makes it false. Two intersecting lines meet in exactly one point. That is true. So we're to think about X marks the spot. So these would meet right here at exactly one point. Points have no size. And that is true. They have no dimension. And here, line XY, and the word denoted here means that you could write it either way. So if I have a picture of line XY, Remember, the order that you write the letters doesn't matter. So this little picture should have been more on top of it. I guess it shifted. But I can name this line as either XY or YX. I could have also spelled out the word LINE, called it YX or XY, either way. Now the next slide, the last one, actually has a picture or a diagram for us to look at. So let's go ahead and take a look at the last slide. Here it says use the diagram to classify if it's true or false. Now let me just clarify a few things. This M that's right here, this is not indicating a point, it's naming the plane. This N is a name for the plane itself, it's not a point, but I'm going to put a little dot next to P because that's just going to be a point. Same thing with A. A is a point. And so are X and Y. So if it's got a dot next to it, these are points. No dots, and it's a capital letter, then it's the name for the plane. So number one, is point P in plane M? That is false. Good. Okay, because I can outline plane M. Plane M is right here, and you can see that P is not in M. Yes?
In that lowercase b, that's just the name for the line, right?
Correct. Good. So the lowercase b, yes, is just naming the line. Okay, B is in M. Is that line in plane M? That is true. Line XY contains point P. False. Good. Because XY is right here, and we can see point P's below it. Plane M contains line YX. True. Good. Point A is on line B. True. Points A and P are in plane M. False. And plane N contains point P. True. See how much easier it is when they give you a picture? It definitely makes it easier. Now, again, I'm not going to grade you on your artistic ability, but if a picture wasn't provided here, you can sketch one out for yourself, just like I did on the other questions. So that is it for your very first lesson. Again, it's learning how to name things and a lot of vocabulary.